Hi, 8th grade. We are on Lesson 3, Session 2, developing and performing sequence of rigid transformations. So remember, this is just saying that a shape can go up 2 and then maybe over left 3, okay? Or it can reflect and then translate. That'd be pretty cool too. Okay, so Kamani and Jake each perform the same 2 transformations on figure T, but not in the same order. So Kamani, she reflects this across the the y-axis, right here. She reflects it across, and then she translates it 4 units to the left, okay? Jake, he translates it 4 units to the left and then reflects it across the y-axis. Will both the sequences map a figure T into the same final image? So we could just kind of like trace this out. I mean, we don't have to like make this perfect because they didn't give us any graph paper or anything. But we can kind of like just kind of eyeball this, okay? So here's where figure T is. I'm not even going to worry about the actual coordinates. I just want us to kind of like eyeball this for a second, okay? I'm go ahead and draw the same thing over here. It's not even going to be very accurate, but that's okay. Just kind of guesstimate, okay? Okay, so let's think about this. If I were to take, this will be the first one, this will be Kamani, okay? And this will be Jake. So Kamani's going to reflect it across the y-axis already, which would put it like this. Okay, so it reflected, it looks like it's about the same distance from here to here. Okay, let me erase my little dashed lines. Then it's going to translate 4 units to the left. Oh my gosh, I'm going to run out of room. So it's going to even go further over here. It's going to go off the paper even, okay? So this is my final image for Kamani. Now let's think about Jake. He wants to move it 4 units to the left, okay? So it looks like it's going to be like maybe right here. Okay, 4 units to the left. Pretend that my shapes are the same. 4 units to the left, then it's going to reflect the y-axis. Then it would be like this. Are they in the same spot? Not at all. The final image for Jake is here, and the final image for Kamani is way over here. Okay, so Kamani and Jake each perform the same transformations. It's just they did them in like a different sequence. This is a great picture to show. So Kamani, her original shape was here. She flipped it, okay, and we got this, and then she moved it 4 units that way. Whereas Jake, he moved it 4 units this way and then flipped it, okay? We could also do this if we didn't have the picture. We could also use just the coordinates of these points. So here's the original coordinates. They're going to be the same for each of these, right? Now they're showing that if you reflect across an x-axis, all it does is it changes the x's to their opposite sign. Do you see how the y's all stayed the same? Okay, I'm going to get my highlighter and show you that with this too. So if I reflect it across the y's stayed the same, but the x's, they are the ones who changed with their negative signs. So all these negative signs are new, okay? And then after that, we learned that when you translate units to the left, that means you're dealing with the x coordinate. Let me grab a pencil here, if it'll let me. If you are going to the left, that means you're dealing with the x coordinate, and if you're going to the left, that also means you're subtracting. And we're subtracting 4 units, so every time they see an x, they subtracted 4. So they had -5, subtracted 4, got -9. -7, subtracted 4, got -11, okay? They just subtracted 4 to each of the x's, but the y's all stayed the same. Can you see that? Let me get my little highlighter again. The y's all stayed the same. Okay. So we just learned a new rule. We've learned this rule. The new rule we just learned is that if it reflects across the y-axis, if it reflects, the x's change to their opposite sign. Okay? Now Jake, he translated first. Okay, so he took x minus 4 first. So here's the originals over here. Take the x coordinate and subtract 4. 5 minus 4 is 1. 3 minus 4 is, or 7 minus 4 is 3. 7 minus 4 is 3. 5 minus 4 is 1. Okay, the y's all stayed the same. Grab my highlighter. Y's all stayed the same. Y's all stayed the same. And we just learned that if you reflect across the y-axis, the x coordinates change to their opposite. So instead of 1, we got -1. Instead of 3, we got -3. Instead of 3, we got -3. Instead of 1, we got -1. Okay? As you can see by our final reflected answers, the coordinates are very, very different. So could we have solved this problem without drawing it? Yes, if we would have known these rules. Okay? So picture it as showing how we can draw it, kind of like how we did right here, and then model it as showing us how we can use math to figure it out. Okay? The big thing I want you to remember is if it reflects across the y-axis, that means x coordinates change to their opposite sign. I bet you guys can assume that if you reflected it across the x-axis, that the y coordinates would change to their opposite sign. Okay, let's answer these questions. Moving my book. Did both sequences map figure T onto the same final image? How do you know? No. So just because they did the same translations but different order does not mean that the shape will land in the same spot, okay? So how do picture and model each show this? So no, comma, picture it shows us the figures in two different spots. Model it shows us how the coordinates don't match up. Okay, how do you know that both the final images are congruent to this original figure T? Well, I know that they're congruent because the two transformations that Jake and Kimani did were still rigid transformations. So I'm going to say Jake and, Kimani. Jake and Kimani both performed rigid transformations. I spelled rigid wrong. And the reason why I'm putting that as my answer is aren't rigid transformations that don't change the shape or the size? So that's how I know. They're rigid transformations, and that's how I know that the final images are congruent. Number 2. Translate figure T3 3 units to the left. Okay? Now if I'm dealing with left, that means I'm going to be subtracting. If I'm dealing with left, that also means I'm going to be dealing with that x, right? So everything that's an x will change. I don't think we need to worry about that because I think I can just go do it in that picture. Then reflect the image across the x-axis. Okay? So let's go do the first thing first. We're going to move it 3 units to the left. So take this guy and go 1, 2, 3. Take this guy and go 1, 2, 3. And then I'll redraw it. Okay, so here's T prime. Now we have to reflect it across the x-axis. So this guy is only 1 away from the x-axis, so it's going to be 1 away up here. Remember, this is our line of reflection. This guy is 2 away, so it's going to be 2 away here. It's 4 away down there, so it's going to be 4 away up here. And it's 7 away down there. I did that really fast because I looked at the numbers. Just so you know. Okay, so this would be T double prime. Okay. Then perform the same transformation in reverse order. Same transformation, but in reverse order. Draw the final image. So basically it's saying if I would go from my t double prime and reflect it, wouldn't it land on t prime? And then if I went from t prime and I moved it back 3 over to the right, wouldn't it then land on my original t? It's kind of a silly question. Okay, so it's just saying if I were to do everything I just did up here in reverse, wouldn't it land back on t? Yes. Do both the sequences map figure t onto the final same image? Yes. You can do the transformation in reverse if you've already done the transformation once. Sorry, I spelled the word "you" wrong. I gotta fix that. Whoa, it deleted everything. Okay, let me read that to you. Yes, you can do the transformation in reverse only if you've done the transformation once. So what that means is over here, the reason why we did it in reverse, Kamani and Jake did it in reverse, but they didn't do the transformation and then go backwards. What they did is they just switched the order of events. Okay, you can't switch the order of events, but you can do the transformations and then go the opposite direction and still land on your original image. Okay, I think that's what they're wanting us to get out of that. What can be different about a figure and any of its images after a sequence of translations, reflections, and rotations? What always stays the same? So what will be different? Well, it's going to be moved. I mean, it might be oriented different, remember? So the orientation will change. But the shape will stay the same size and shape. I mean, it will stay the same shape, right? So that's why I'm going to put that. The orientation will change. Orientation means like where it's located. So the orientation of this did move, right? Now it's already in the quadrant number 1. So the orientation changed, but did the shape itself change? Like it doesn't look different. Even if I were to reflect it and it's like different looking, it's not a different shape. It's still the same shape, it's just changed its orientation. Okay, number 4. Think about all the different models and strategies we have discussed today. How was one of them more helpful to you? So what I want you to do is I want you to ask yourself, are you somebody, let me erase my doodlies. Are you somebody who, on this question, you wanted to do drawings, like me, like that's what my first thought was, I'll do drawings. Or are you someone who you prefer to do the rules and just find like the coordinates and then know the rules that say if you're reflecting, you change the x-axis, you change the y, if you're reflecting across the y-axis, you change the x's. If you're reflecting across the y-axis, you change the y coordinates. If you're someone who likes those rules and like has those down naturally, that's great. If you're somebody who likes to visualize it, that's great too. So on number 4, I want you to pause the video and I want you to fill this one out on your own. Tell me your opinion. Do you like the picture it or do you like the model it better? Okay, number 5. Rotate the letter W 180 degrees around the origin and then translate the image 4 units up. Draw the final image. What new letter did you form? Okay, so if it's going to go rotate 180 degrees, it's going to end up in this quadrant. I know that because it's the opposite side and that's a straight line, right? If it was in the quadrant below, let me erase my line for a second. If it was down here, that's 90 degrees. If it was to flip right here, that's just 90. So I want 2 flips, which is 180, okay? So let's see, we're not gonna flip it, we're gonna rotate it. I gotta remember that. So it's rotating around, which means I'd still have a line on 4, but it would be down here, right? Rotate, rotate, rotate. And this one would still be at 4, 4. 4, 4. And this one would still be at 2, 2. And then this one would still be at 1, and this one would still be at 3. Okay. So if it were to rotate, that's what it would look like. Okay, now it wants me to translate that 4 units up. So take each of these points and just move them 4 up, okay? 1, 2, 3, 4. Ooh, I'm gonna use a new color. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. What new letter did we make? M. Is the new letter congruent to the original letter? Yes, because did it change size? No. Is it the same shape? It just is rotated and flipped? Actually, it's just rotated and slid. But so, is the new letter congruent? Yes. It's the same shape and size, just in a different spot. Or the orientation changed. Number 6. A sequence of transformations is performed on a figure. Then a different sequence is performed on that same figure. The resulting images are not in the same position. Are they still congruent? Yes, you guys. Congruent means that the shapes are the same shape and size, just maybe in a different spot. So it's literally going to be like the same question that we just had. Yes, the shape and size didn't change, just the location. Okay, number 7. Translate figure Z 3 units to the left, then translate the image 5 units down. Draw the new image, okay? So 3 to the left. Left is this way. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so there's Z prime. And then it says to do what? 5 units down? I'm gonna use a new color. 1, 2, 3, 4. Did it say 5 units? Ugh. Or am I just reading this wrong? No, 5 units, okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sweet. Did that. Now perform the transformation in reverse order. Draw the image after each transformation. Okay, so in reverse order means I would go 5 units down, and then, oh no, so it means go over here and do the original Z, go 5 units down, and then go 3 units to the left. Okay, so let's try that. I'm gonna do some new colors. You know what I'm gonna do? I'm gonna do pink was our first transformation, so I'm gonna erase this guy and change him to be pink. Okay, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so pink is the first way. Red will be the second way. Okay, so red wants us to go over first, right? Oh no, 5 down first. So we went over last time, now we're gonna go down first. So 5 down. Let's see, 1, 2, 3, 4, 5. It's gonna look something like, maybe not that. 1, 2, 3, 4, 5. Okay, so we went down first. Okay, down first. Now I'm going to slide it, what is it, 3 to the left? Yep, 3 to the left. Okay, so now let's go 3 to the left. Ready? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So did I get my Z to land back on Z? Yeah. So what we just learned is you can go over and down, or you can go down and over. And that makes sense, right? It doesn't matter which way I go. I could go over then down, or I could go down then over. It's still going to land on the final new image right there, okay? Okay, so draw the image after each transformation. So now we can put a little check mark, say we did that. Do both sequences map Z onto the same final image? Yes. I can go down, then over, or I can go over, then down. And I'll still get on the same image. All right, guys, that is the last page. So 52. 52 is what you need to scan, and then you need to upload, okay? 53 and 54 is what we will do in class. All right, guys, see you soon.